Okay, now I am just going to finish up a few more examples of how to calculate various items from your text. So here we have Richard Gorman. He's 65 years old and about to retire. He has 500,000 saved to supplement his pension and Social Security and would like to withdraw it in equal annual dollar amounts so that nothing is left after 15 years. How much does he have to withdraw each year if he earns 7% on his money? Now, obviously, this is some kind of annuity problem because we're talking about withdrawals of annual amounts, which is kind of solving for payments, right? And here, as we look at this, what are we solving for? We're solving for how much how much per year he can withdraw. So it's a lot like a loan amortization problem. And so we look at the numbers, and what do we have? The numbers we have are the present value, because he saved 500,000. His interest is 7%, and that he thinks he's going to earn over the next 15 years. And 15 years is n, and the future value is 0, because really what we want to learn is what annual payments can he take out to get to a future value of 0. So how do we do that? We compute the payment by plugging in the numbers. Plain and simple. Another way you can do it is by looking at the factor. You can look it up in the book. And what factor would you be looking at? Which one? You'd be looking for the present value interest factor, 7% for 15 years. Go to the table, and remember the formula is the present value equals payment times present value interest factor. So we have two ways of computing this, but via calculator or with the interest factor. So the present value interest factor is 9.108, so we have to divide our present value by that factor to come up with our annual payment that will bring us to 0. Now, let's assume you're 25 and earn 35,000 per year. You never expect to receive a raise and plan to retire at age 55. If you invest 5% of your salary in a 401k plan, returning 10% annually, and the company provides a 50 cents on the dollar match on your contributions up to 3% of your salary, what is your estimated future value? That's question number 1. Question number 2 is, once you retire, how much can you withdraw monthly if you want to deplete your account? So what are we solving for? First of all, the future value of a stream of payments. Then secondly, how we can withdraw to get to 0. So kind of like the last problem. Both require you to figure out monthly payments. First, how much money is being invested each year? We need to know that, don't we? To calculate. We need to know how much it is. So if it's $35,000 at 5%, and there's a match of, half of 3%, because that's the amount of the salary that the employer is matching to. That's extra money that he'll get. So you divide that in half because it's 50% of it. It's not a full dollar for 3%. It's 50 cents. So all you have to do is add the two numbers together, 5% plus 1.5%. And so 6.5% of the salary is being invested. And what would the payment amount be? 35,000 times 6.5% equals an annual payment of 2,275. So now we can fill in the formula to complete it. So the future value of an annuity equals annual payment times the future value interest factor, which is table C. The future value of 2,275, right? Our future value equals the payment 2,275 times the factor 10% on 30. Look it up in your appendix, and it will give you 164.491. And therefore, your future value equals 374,217.03. Now, if you want to do it with using the calculator, it's a little bit different. You would input what? 10 is your interest rate, because it's right up here. 30 and the difference between 55 and 25, this is 30-year problem. 0 present value, 2,275 payment, and then we would compute for the future value. And we end up with 374, 223.90. So that's very, very close to if we had used the factor. Now, it's the future value becomes the present value for once we retire. So the present value, our next calculation is, given that I've got this amount of money at 10%, what do I have to do to bring it down to 0 over a 30-year period of time? Interesting. And we want to withdraw this monthly. So now we've got to change over to our monthly calculation. To me, again, the easiest way to do this is input your present value, your negative 374,223.90. Input your interest rate at 10 divided by 12, which is 0.833. N is 30 times 12. We've got to marry up all the factors. 30 times 12. So N equals 360. We have 0 future value, so if we're going to compute our payment, doing it this way, it comes out to 3,284.08. Now, of course, you can always go to using the calculator, and then if you don't want to put in the interest rate as 0.833, then you can always go change your payment flow, your PY, from 1 to 12, and then you can input 10 once you change your payments. This example is a strange one, but I got some questions on it, so I thought that I would share the answer with you. Usually, if you lose money, and it's sunk cost. So the trying to calculate a rate of return on a negative number just it really is not done very often, but that's what this example is. 7 years ago, he purchased a wooden statue. He paid $7,600. Now he's getting rid of it for $5,200, and so he takes a loss on the investment. What's his rate of return? Well, his rate of return is obviously going to be negative because he's selling it at a loss. So at the time he bought it, we'll do it from the time he bought it. Present value, negative 7,600. Future value, 5,200. N is 7 because it was 7 years. And his so now we want to compute for the interest rate. So when we compute it, it'll come out negative, a negative 5.28. That's why I put the present value of 7,600 in as I did, because it would automatically make that interest rate a negative 5.28. Again, not the type of problems you'll have a lot of or should in the future, but it is what it is, right? And then example 4, Chris Griffin has this realistic, very realistic one. Chris Griffin has $5,000 debt balance on his Visa card that charges 18.9% compounded monthly, and his minimum monthly payment is 3% of his debt balance, which is $150. How many months, and we're going to round up, will it take Chris to pay off his credit card if he pays the current minimum payment of $150 at the end of each month? So here we go. We've got a couple of things to calculate here. We are calculating how long does it take to pay off a debt. See, we're talking a loan problem here. So how much is it going to take us? How much long, given we're paying only the minimum of $150? So we have to look at the problem and say, what do we have? Well, we know the interest rate is 18.9% annually. We know that we're making a $150 dollar payment each month, and we know that our present value is $5,000, and our future value is zero, and because that's what we're shooting for, right? And we're going to compute n. N is how long. Remember, again, to convert IY to monthly, so you either divide by 12 or change PY from 1 to 12. I divided the interest rate by 12, 18.9, and then I input interest rate as 1.575. I input my payment as a negative 150. I input my present value as 5,000 and my future value as 0. So when I computed n, it looks like it's going to take 47 or 48 months to pay off this debt. That's a long time. And this is not an unusual example. So the whole idea is to pay more than your minimum balance on your credit card. And you can see the difference if you just up your payment by $50 per month and the same interest rate, same present value, same future value, computing n, you're now down to 33 months. So every time you increase your payment, obviously n goes down, and that's the concept of this question. And then this is the final example that I wanted to give you. Again, how long will it take to pay off a loan of $50,000 at an annual rate of 10% compounded monthly if you make monthly payments of $600? What type of problem? We want to answer how long, how many months. So what information do we have? We pull it out very easily. $50,000 is our present value. Our interest rate is 10%. Our payments are $600 a month. Our future value is 0. We want to compute to n. In order to get the proper timing, we've got to marry up our timing to months. So again, you either change your PY to 12 in your computer before you do your calculation, or divide your interest rate by 12. And if you do it the way that I did it, which is divided the interest rate by 12, then I ended up with 143 months to pay off this debt, which is quite large, or 12 years. That's a long payment stream. Okay, I hope all the examples that I've given you have been of some help, and good luck. Hope you get your homework done and that it makes a lot of sense to you.